Hey guys, I'm back. This is SirMathman here, and I know I haven't been active on my channel for a long time, and for good reason too. I haven't really found time to work on my channel, but I realized that since I have tons of free time and I'm doing tons of things, why don't I just record them and then share with them with you guys to show what I'm doing. So right now, I'm going to start this new series called Infinity. And the reality is that I've worked on this project for quite a while. I have a few branches here, as you can see. But I wanted to start this new saga where the whole entire thing is essentially recorded and documented onto YouTube. So you guys can follow along with what's happening. And also, this is kind of a form of a documentation, so you don't have to manually write out code. What I can do is that in my pull requests, I can just mention these YouTube videos that I've done. In this way, that forms essentially the form of documentation, so you don't have to physically write things down myself. So I've done a lot with this project already, so I kind of understand the general idea, and I'm going to explain the general idea in a second. But let me just pull up, I don't know, come on Cortana. It's a bit slow today. But you see some extraneous files in the file system up there. I'm just going to pull Paint so I can go ahead and draw you guys a diagram. It's too bad they decommissioned Paint. I would have loved to have that thing earlier. But we have a few files already. So we have Gradle. We don't need Gradle because we're not working with Gradle. I forgot to delete that earlier. But let me just close out all this. So before I tell you what the idea is about, this is just a simple repository. Let's just say remove Gradle because I really didn't need this anyways. Okay, apparently it doesn't matter anyways. I deleted those things. Oh well, so get ignore, this just blocks out the IDE. Back to the idea. So when I found this problem with inefficiency, and I'm obsessed with this idea of being efficient, getting the most amount of work done in the minimum amount of effort or time. And as a result, I found that it's difficult for programmers to program with each other on advanced projects when we have multi-file systems, because if you go to Google, we have Google Docs, which is very, very nice. However, the only problem is it's only one file to one file. We could set up a folder system, but again, we can't really export things to Google. We can't really add in build systems. We can't really do anything with that. And so what happens is that there needs to be a tool that allows us to do these kinds of things simultaneously with other people. And when I mean things, I mean code. Program computers simultaneously. And the reality is that that's a very difficult thing to do. And I say difficult thing to do because there's multiple outcomes that could happen. So while that's updating and building the cache, I'm going to go in here and explain what I mean. So this is going to be an abstract thing. So one of my friends complained that of using a socket connection, but we're going to use that for the time being because that's relatively simple to easy and set up. Relatively easy to set up. So it's just plain old server, right, like this, and then you have your multiple clients out here. I don't know. And then just make some lines. Like so. I really hate that they decommissioned Paint, but okay. But this is generally speaking, there's server I/O is happening, but this doesn't really tell you what's going on. So what you want to do is that, so essentially what it's going to do is that, so if you look at Google Docs, it's going to, if you write out like, I don't know, hello world, something like hello world, and then another person types at the same time, it's going to automatically update, right? I don't want this because in reality text is not really helpful. So the idea is to get that same thing done with code. And that sounds easy, but it's really quite difficult because many outcomes can come as a result of programming. And for example, let's say we're modifying something on the file tree. Alright, so is it going to appear on the client or is it going to appear on the server? Or if something appears, if a window appears, like this one, is this going to appear on the client or appear on the server? If we're making something that involves the client, like let's just make a main class quickly to show you what I mean. So if I do extends application, my ID is a bit slow today. Launch args, and I'll just import. Then we just stage, primary stage, just hit stage, new scene, new anchor pane, like this. This guy just generates a window, but the question is does this window appear on the client or on the server? And when I mean this window, I mean any windows. Oh, come on. That's because I had this runtime configuration up here. That's kind of annoying. But let me just run this again. But yeah, it's gonna appear on the other screen, so that's why you can't see it. But it's just gonna appear for blank window. Now, will this window open on the client or the server? I don't know. I can't tell you that. Let's say we're making a game. Can we make Unity networked? I mean, not Unity multiplayer network, but I mean the Unity editor networked, on which multiple game developers could edit multiple things at the same time. Now, that could be a fundamental revolution in software engineering, because this way we change things from a vertical process to a horizontal process, or it might be the other way around. I don't remember the exact terminology, but what we're doing is that we're moving things away from doing things in assembly line fashion, A plus B plus C plus D plus E, into something that's done all simultaneously at the same time. And this allows us to cut down, because the first revolution was the assembly line, when we're able to rapidly produce things because we have amassed a lot of goods and we're able to execute things rapidly in series. But since programming and art and things like that are much more creative works, we can't really do the assembly line pattern. Sure, we could try to automate something or do an assembly line workflow or an assembly line workflow when it comes to computer graphics, but oftentimes that's not necessarily the case. Oftentimes it's necessarily the process of a bunch of artists coming together and creating a masterpiece, and that masterpiece is simply put on display. There's no real A plus B, or no, A to B to C to D. It doesn't really work like that. And as a result, it's kind of a misnomer. So let's go ahead and so that's the idea for the project. Just gonna clean some directories right there. Right now, this is just an empty slate, and even though we are doing a Java project, as you can see here, I'm working with SBT, which is the Scala build system. Originally called Simple Build System, but they realized that was a horrible name since nobody could understand it in the first 30 minutes. So they changed it to Scala Build System. I said Scala before, I mean Scala. And let me clear out this target folder as well, since I really don't need it. But as you can see, the Scala build system really likes to keep a lot of files compact, and that's great because this way we don't necessarily have to deal around with a lot of file clutter. And also it's easier to work with, because with the Gradle, yeah, I don't know why, but I've always had issues with Gradle, with testing, etc. It's a bit difficult to test and run the tests here. But if I just go ahead and find, I don't know, tests, not set, reboot. Also, the thing about my IDE, IntelliJ, is that I don't really test things manually using the build system. I could, but I don't test it right here. So test execution, test filter, test options. So it really gives a lot more freedom when it comes to writing tasks and or just it has a lot of built-in tasks already, publish to Maven, etc., etc. But this is all of this, so we're going to work with that in the future. I'm not going to focus on it now. You see some dependencies in front of you. This is just the main class. Let me cut this out. Content at the main. Infinity version, we'll change this to 0.0 since we are no longer in development. I'm not going to touch the Scala version. And we just have some dependencies here. So this is just JUnit 5. This is just test effects, which allows us to test Java effects, because apparently you can't run unit tests on the FX thread, which is really stupid, but it makes sense to have a specifically devoted thread. And then we have simple logging for Java. I'm not sure if I'll use this too much, because I'm going to actually build up my own custom logging system down the line. And as a result, it's kind of one of these things that could be used, but it's not really redundant. And reflections, I'm going to use reflections for a module loading. And let me just make a commit that says something like this. Change update build a SBT for new version of project. There we go. And I'm going to do commits like this often. So if you are following along with me, you're going to learn to commit often. And so I guess I'm not going to start any code now. I'm going to start in the next episode. So I just wanted to introduce you to guys, what exactly this project is about and what it's about and what environments I'm going to be using. What it's going to feel like. But this is really just an episode if you'd really like some backstory. So I guess we'll just end the episode here, since I would like a logical jump between episodes 1, 2, 3, 4, 5, etc. Actually, we're going to call it episode 0. Because, again, programmers start from 0. If a programming language starts counting from 1, then we have some definite moral and ethical problems. But besides that, this is really just a bunch of exposition. And next episode, we are going to get to programming, which is the fun part. So I guess I'll see you guys then. SirMathman out.